Assalamu alaikum. In today's section 2.8, it is the derivative as a function. In previous sections, we considered the derivative of a function f as it's shown in the slide. F of prime of x is equal to the limit of this formula, which is f of x plus h minus f of x over h. And we called it the derivative of the function f, and it is the same as the slope of the tangent line to the graph of the function f at the point x and f of x. Here we have a question. It asks us to sketch the graph of this function, the derivative of this function actually, and here we have the solution. Let's see what they did. We can estimate the value of the derivative at any point of x by just drawing the tangent at any point x. Like for example, let's take x equal 5 here, and let us draw the tangent. They call the point P. So if we draw the tangent just like this, okay, it's not a straight line, but okay, let's, as it's shown, it's a straight line here, and we can just estimate, because we don't know all the values of the function, we just can estimate the value of the slope, and the book estimated the value as 3/2, so we can see that the derivative at x equal 5 is equal to 3/2 or 1.5, and this will allow us to plot this point in the graph of the derivative of the function directly here, and this means that the slope, it will be this point, it will be x and f prime of x, so it will be 5 and 1.5 or 3/2. This means that the slope on the graph, the original graph f, becomes the y value on the graph of the derivative of the function. So we just can put it and plot it here. It is x and estimating the 1.5 just like this. Okay, and we will repeat this procedure at the several points that are clear, that we can estimate the slope for these points. We can see that the tangents at point here A, B, and C are equal, are horizontal tangent. So the derivative at that point will equal to 0. So what we're gonna write is at this point, let us estimate it as 0.4. So it will be, in this graph, it will be 0.4, and the value of the derivative at that point will be 0. So we'll draw it just like this, and the y value will be 0. Same at point B and C. The derivative here will be equal to 0, f of B is equal to 0, f of C is equal to 0, and f prime of A and B and C equal to 0. Okay, what about the points between A and B and A and C and B? What we're gonna do, we can see between A and B, the tangents at that point, all these points have a positive slope. So the derivative of the function is positive there. And we can see here that this point here is the point that the concavity will change. So it will be the second, that means that the second derivative will equal to 0 at that point, which is 0.4, it will equal to 0. That means that because the slope in this interval will be positive, so in the f prime graph, the derivative of the function, the graph of the derivative of the function will be positive, which means above the x-axis, it will be this part. Okay, let me erase it, and it will be this part. And same for the points between B and C, the slope here will be negative, so it will be below the x-axis. And here we have, I think here we have the points that the concavity will change, so it will be here that the second derivative will be equal to 0 at that point. Here it will be 0, and here it will be 0. Same between C and P, the slope in this interval is positive, so it will be above the x-axis. Okay, let's see this example. It's asked to find the first derivative of the function 1 minus x over 2 plus x. We will use it, or we will find it. We will find it using the definition of the derivative. We showed to you in the first slide in this section, which is f prime of x equal to the limit of f of x plus h minus f of x over h, and h goes to 0. What we're gonna do, we will just substitute the function, the original function, 1, well, let me put this one, yes, and 1 minus x plus h over 2 plus xh minus 1 minus x over 2 plus x over h, and here don't forget the limit, h goes to 0. Okay, now we will put these two together and we will unite the denominators. Okay, now let's simplify. We are gonna delete this 2 with this 2, and the minus x with the minus x here. Let me change the color. We deleted this one, and this one with this one, and the minus x squared with this one, and the minus xh with this one. We will leave this one and this one, minus 2h minus h. This will give us minus 3h over h, 2 plus x plus h, 2 plus x, and we're gonna delete the h from here, and the h goes to 0. So we're gonna have the limit of minus 3 over 2 plus x plus h, 2 plus x, as h goes to 0. We're gonna just substitute the h by 0. So what we're gonna have is minus 3 over 2 plus x times 2 plus x, which is 2 plus x squared, and this is the derivative of the function 1 minus x over 2 plus x. Okay, here we have a definition. It says that a function f is differentiable at a point a if the derivative at that point exists and it is differentiable on an open interval a to b, or a to infinity, or minus infinity to a, or for the whole interval minus infinity to infinity, if it is differentiable at every number in that interval. So here we have a question. What is the function f of x is equal to the absolute value of x differentiable? If x is positive, that means that the absolute value of x is equal to x. Therefore, we will have the f prime of x is equal to limit, when h goes to 0, the absolute value of x plus h minus absolute value of x over h, which is equal to the limit, since it's positive x plus h minus x over h. This will delete this one and h goes to 0. So we will have the limit of h over h as h goes to 0, which is equal to 1. And therefore the f of x equal absolute value of x when x is positive is differentiable. For any x, okay? For any x bigger than 0. Same thing when x is negative. If x is less than 0, we will have the absolute value of x is equal to negative of x. So we will have f prime of x is equal to the limit of the absolute value x plus h minus absolute value of x over h as h goes to 0. we're gonna have limit of minus x plus h minus x over h, and h goes to 0. Now we're gonna delete this one with this one. Minus x plus x will give us 0. So we're gonna have the limit of minus h over h as h goes to 0, which is equal to -1. And therefore the function is differentiable for any x. F of x equal absolute value of x is differentiable at any x less than 0 and x bigger than 0. What about x equals 0? For x equals 0, we're gonna have f prime of 0 equal limit of f of 0 plus h minus f of 0 over h when h goes to 0. So this will give us the limit when h goes to 0 of the absolute value of 0 plus h minus the absolute value of 0 over h. This will go with this one, and we will have limit of the absolute value of h over h as h goes to 0. So we don't know now if it exists or not yet. So let's compute the left and right limits separately. The limit of absolute value of h over h as h goes to 0 from the right will give us limit of h over h, which is 1 when h goes to 0 from the right, and the limit of absolute value of h over h when h goes to 0 from the left will give us minus h over the limit as h goes to 0 for minus h over h will give us minus 1. Since these limits are different, therefore f prime of 0 does not exist. F prime of 0 does not exist, and therefore the f equal absolute value of x, f of x, is differentiable at all x except at 0. And we can write it in this way: f prime of x is equal to 1 when x is positive and -1 when x is negative. Okay, here we have a theorem. It says that if the function is differentiable at a point A, then for sure the function is continuous at that point. But let us take a note, and it's an important note: the converse of this theorem is false. Why? Because we have functions that are continuous but not differentiable. For example, just the example that we saw, the function, the absolute value of x, it is continuous at 0 but not differentiable at 0. Why? Because the limit of the function x, which is absolute value of x, when x goes to 0 is equal to the limit of the absolute value of x when x goes to 0 equals 0, which is equal to the value of the function, which is equal to 0. But in the previous example, we showed that the function f absolute value of x is not differentiable at 0. And that's it for today's section.